Today's lesson is about similar figures and how to solve them using proportions. So let's kind of read the first question. It says, if triangle ABC is similar to triangle XYZ, angle A is 50 and angle C is 30, what is the measurement of angle X? So the first thing we kind of want to think about is what similar triangles have in common with their angles. So I'm going to go ahead and just draw my figure. I'm going to make this A, B, and C, and so there's no confusion. I'm going to keep it turned the same direction. Z is going to go up top, then I have X and Y. One important thing to know is kind of what angles go together. So remember, just like in congruent figures, A is first, Z is first. A corresponds to Z. Next, we've got B and X. B is middle, X is middle. So I've purposely drawn these the same direction just to kind of make things a little bit easier on me. Okay, now I'm going to use the actual problem. So I'm going to start, angle A is 50, angle C is 30, and we need to find X. Now we know X and B have to go together, so I'm just going to stick X over here. To solve for the measure of angle X, I'm going to solve for the measure of angle B. So 50 plus 30 plus X equals 180. When I subtract 80, X is 100, which is option 4. Now, one very important thing to know is if you have similar figures, the angle measures always stay the same. So I'm going to go ahead and kind of go over here with some binder clips. As far as the side measurements go, the side lengths on here are going to be proportional. So this side is proportional to this side. However, this angle here is the same as this angle here. So as the shape enlarges or reduces, the angle measurements actually stay the same. So that's why in this problem, it's just kind of trying to trick you. The angle measurements will always be the same. So if angle B is 100, so is angle X. All right, let's try our next one. If in the accompanying diagram, triangle QRS is similar to triangle LMN. So I'm going to pause here, and I'm going to match my figures. Q is first, L is first. Q corresponds to L. Okay. Then I've got R and M, R, M, R, M. This kind of just helps me determine how my shape is turned. There you go. Now, in order to find what length I'm solving for, it says solve for the measure of ML. I'm going to go ahead and put an X here. I don't know what it is, and it's asking me to solve for it. There is a lot of info on this picture, but one of these sides I don't need. Now that I've matched my angles, I can see that from orange to green, there's nothing here. So on this problem from orange to green, I'm not going to use 27. It's just there to throw me off. So now comes the time I set up my proportion. There are a ton of different ways to do this. I kind of always go one shape to another. So orange, yellow is 30. Orange, yellow is X. 30 over X. Since I started at the big triangle, I need to go back and start at the big triangle again. Green to yellow, green to yellow. 21 over 7. Now, it's important to know that I can do this multiple ways. I could have gone X to 30, 7 to 21. That would have flipped my fraction. But I need to go in the same order every time. So if I start at the big triangle and go to the little, for my next ratio, I need to start at the big and go to the little. Okay. From here, I cross multiply. So 30 times 7 is 210. And then X times 21 is 21X. When I divide both sides by 21, I get an answer of 10. So my length of ML is equal to 10. Similar figures are all proportions. Let's try a word problem. So it says, a lamppost is 6 feet high and casts an 8 feet shadow. The same time of day, a flagpole directly behind the lamppost casts a 28-foot shadow. Now, I've totally cut off the question. The question is, what is the height of the flagpole? So what we're going to do is I'm just going to kind of match my sides. The way I always do this is height over shadow. So height over my shadow equals height over shadow. I always kind of want to go height over shadow. Okay, height over shadow. So how tall the shape is first over its own shadow. Height of the flagpole over shadow equals height of the lamp over shadow. And then I cross multiply. H times 8 is 8H. And then 6 times 28 is 168. Dividing both sides by 8, I get 21. So the height of the flagpole is 21. I always just go height over shadow, height over shadow. It's a little easier to make sure that kind of you're keeping the same thing in the top. So height, 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 shadow, shadow. It kind of self-contains the problem. Height of the flagpole over its shadow, height of the lamppost over its shadow. Now you can always go height to height, shadow to shadow, but it gets a little confusing. That's why if you keep it in the same picture, it's going to be a little bit easier. Remember, solving for similar figures is all proportions.